This is the solution to pre-check problem for the test, set number 1. A .045 kilogram golf ball is hit from rest. The golf ball's club force acts on the golf ball for a distance of 0.12 meters. The ball leaves the golf tee at 70 meters per second. How much power did the golf club exert on the ball? You need to know a little bit about golf, and that's the fact that when the ball is sitting on what's called a tee, it's not moving at all. It doesn't move until the golf club finishes applying a force to it. So something's implied in the problem. That's initial velocity is equal to 0. All right, I'm kind of overwhelmed for a moment, so let's just list the givens. I don't know where else to start. So the mass is 0.045 kilograms. It's hit from rest. That's when it's on the tee. So the initial velocity is equal to 0. And the golf club exerts a force across a distance of 0.012 meters. And the golf ball leaves the tee at 70 meters per second. How much power did the golf ball exert? So let's see. Power. Well, with power, I have 3 equations for power. Power is the change in energy over time, which is work. So work is force times distance over time. And distance over time is average velocity. So that's the same thing as force times average velocity. Wow. So I've got a lot of ways of finding the power, and I need to choose one. I'm going to choose force and distance over time just because it looks nice and simple. So let's see where we're going to go with this. If I use force and distance over time, well, I'm going to find the power, and I'm going to find the power. That'll be the last thing I do is find the power. And when I find the power, I'm going to use this equation, FD over T. All right, so I'm going to find the power. Oh, but to find the power, I got to find the force. Well, to find the force, I got to think back to F equals ma. And I don't have the acceleration, but I do have a lot of things I can find with these kinematics equations. So I guess I'll find the acceleration in the process. Okay, so that's good. And I've got the distance. Oh, but let's see. So if I find the acceleration, I also need to find the force. And then I need to find, let's see. I need to find something else here. I need to find, oops, everything moved. Find the time. Ooh, I'm doing a lot of work here. So I'll find the time first. I'll find the acceleration second. I'll find the force third, and I'll find the power last. So let's look at the time. Let's see, to find the time, I'm going to use, I'll write over here, I'm going to find time so you know what I'm doing. X over T equals V plus V naught over 2. So X over T, X is going to be 0.012 meters divided by the time, and that's equal to the final velocity, which is 70 meters per second, plus 0. So I'm not going to write the zeros because we know it's just going to go away anyway. So 70 plus 0 divided by 2. And now what I'll do is something called cross multiply to get my T. So I'll take those and cross multiply. That makes this 70 times T is equal to 2 times 0.012. That's going to be 0.024. And then T, well, to get T all by itself, what I'm going to have to do is I'm going to divide both sides by 70. Since it's 70 times T, I've got to divide it by 70 to get T all by itself. So that'll leave me T on the left, and on the right, it's going to give me 3.42857 times 10 to the negative 4 seconds. All right, so that's the time, really small number. Now what I want to do is I need to find the acceleration. So I can find the acceleration with the time, but I'm going to try to find it without the time in case I made a mistake. So I'll make a little note up here. Find the acceleration. So if I find the acceleration, I'm going to use v squared equals v naught squared plus 2ax. So that'll be 70 meters per second squared equals, well, it's going to be 0 squared. I'll put that in there anyways. Plus 2 times a, which is my variable I'm looking for, times my distance, 0.012 meters. All right, so that's going to be 70 squared, and 70 squared is 4,900 equals, all right, so this is going to be 2 times A times 0.02, so I can rearrange this just to make it 2 times 0.02, or 0.012, I mean. So that'll be 0.024 times A. Now to get the A all by itself, what I need to do is divide both sides by 0.024. Divide this side by 0.024. And that's going to give me an acceleration, which is really big, of 204,166.6 repeating meters per second squared. Big acceleration. Fortunately, it doesn't act for very much distance or very much time. So that's really good, but that's a big acceleration. All right, so that's the second thing. Now I'm going to find the force. So I'll make a little note here. Find the force. So I know what I'm doing. F equals ma. So F equals 0.045 kilograms. It's the mass times the acceleration I just calculated. 204,166 meters per second squared. And when I do that, I get a force of, 9187.5 newtons. So that's the force. So there's the time, there's the acceleration, there's the force. Now I have enough to find the power. So let's go for the power. Power is equal to force times distance over time. So power is equal to the force, 9187.5 newtons, times the distance, 0.012 meters, divided by the time, which is 3.428 times 10 to the negative 4 seconds. So the power delivered by the club is 32156 2.5 watts. So if I wrote that with 3 sig figs, that would be 322000 watts. And in case you're wondering, that's about 431 horsepower.